Dun, 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 dun. All right, well, it's time again for Astronomy Daily Live. It's 2 hours UTC. Welcome, welcome. Come on in, friends. Everyone, come together here, gather in the circle of friends to gather daily and think and talk all things astronomical. So come on in, welcome. I've got some really hot coffee right here, sort of freshly brewed coffee, and yeah, just the regular HOH tonight. So I'm gonna keep it a little bit calm. So cheers to everybody. And in the panel is Bobby. Hey there, Bobby. What's going on?
Hey, what's up? And what's up, Uncle Bill?
Uncle Bill's already in the
Bill
chat.
Goddard.
Uncle Bill
And
is
there's
already.
Tom Van Scudder, and I'm about to switch that to the live.
Hey there, Tom. Nice to see you in the chat also. Thank you, Uncle Bill, because I would have forgotten again. I'm all, it's all I have to do is press the tweet button, right? It's all I have to do is press the tweet button, and I don't do it, and I'm going to do it over on Discord too. Like that. Chunk. Yay. Okay. Thank you, Uncle Bill. Awesome. So yeah, so come on in, friends. We're going to think all things astronomical for about the next hour or so. Now, I'm happy to report that after the live stream yesterday, I did exactly what I was going to say, and I ordered a mic stand. I actually found this. I don't know how I got this, but that's well, it's a little too short. so yeah, I actually ordered a mic stand, and it is on its way. So it's supposed to be here, sometime next week or so. And yeah, I mean, it's an absolute fact that with a mic stand, life is going to get a little bit easier because I'm not going to have to hold this thing, and I'll really be able to wave my hands around and everything like all good scientists do. Lots of hand waving, right? So cheers to hand waving.
Yeah, and welcome, Bob Dog.
Hey there, Bob Dog.
And Atolata.
Tawahinta. Tawahinta. Hey there. Nice to see everybody in the chat again. So yeah, I was just mentioning to Bobby that it's actually been cloudy here all day long, and that's sort of the season. But in the last hour, right? In the last hour, it just all the clouds just absolutely vanished. Now I don't mind that it's getting clear because I just collected some data the other night, and I've just begun to look at it. I've actually gone through a process that's called reduction, and that's just sort of what the name implies. I'm reducing the data to its elements, right? So raw data has the actual data from like the stars, the brightness of the stars, whatever I'm looking at, right? But it also has all this instrumentation stuff. It sits on top of a dark, and it's sort of biased by various kinds of gain and all the optics and the telescope and everything else. And I want to remove all of that. So just like in cooking, right? When you do a reduction, right, you throw out all this stuff, and that's exactly what we do. I think I think I can say this with pretty clear certainty that every single science, when you collect data, you have to do some kind of data reduction, right? You have to take out all the systematic stuff, that's part of the instrumentation, all those things that shouldn't be part of your signal at all. You have to try to remove. So I've done that, right? And the data looks good. So I've started, to sort of run it through my data reduction mill, and there's always weird problems and stuff but it's not anything major or anything like that. I just have to tweak the code a little bit. That's one of the cool things. It's one of the nice things about being a programmer, right? Is that I'm not just stuck with one piece of software that I can't change, right? If there's any kind of problem or anything, I just have to go into the code, make the change, recompile it, done, right? So that's a nice thing. So yeah, that's sort of an ongoing thing. I should actually have some results from that hopefully in the next couple of days, and I will make sure to share those results here, because yeah, this is it's sort of an ongoing project, but it's a new set of data, sort of learning from the past, the kind of data that I want, and I think this is going to be pretty good. So I just have to run it through the software and make sure that the software knows how to deal with it. So that's sort of what I'm working on at the moment. So cheers to data. I'm going to start up my smartphone here so I can monitor the live stream as well. Da-da-da. Like that. Okay, cool. So is everybody in? Everybody in? All right. We'll let the show begin. One more feed. All right, well, awesome. So I was watching Fraser last night. He was back on the telescope. And Fraser is a really, really smart guy, right? So he learns really, really fast. And he's now, the first bit, that he was messing with the telescope, and then the first live stream he did with Skylius, he was like all over the sky, whatever, and I mean, it was great, right? I mean, it was really, really great, but it was kind of scattery, and the images were pretty good, but the focus was really, it's just driving me insane, and all that. So last night, he got back on, and he was organized, right? He was organized. He's like, I have a list of 200 objects in Cygnus, right, in the constellation of Cygnus, okay? And I'm going to go through these one by one, right? I'm going to point the telescope. I'm going to do a 60-second exposure, and I'm going to look at it, and I'm going to evaluate it. Because I mean, what he wants to do, right, is he wants to get, when he does this live stream with Skylius, right, what he wants to do is he wants to show off some really cool stuff, right? So, he doesn't want to just show off, field after field after field of stars, right? Which, to me is like really, really cool, right? I mean, I get a lot out of that, but I can understand, people who who are new, who don't necessarily really care. They want to see cool stuff, right? They want to see really, really neat things that are stunning, right? So he had this list. Now I think I watched him for maybe an hour and a half or so. I'm not exactly sure. And excuse me, he had made it through. I don't know how many by that time. Maybe 40 to 50 or something like that. He was going through them pretty fast, and he had um, he had definitely picked out a few that were really, really kind of cool, right? The North American nebula is really, really cool. There were that region of the sky. There's a lot of um, um, open clusters and a lot of nebulae. So most of the objects he was looking at were those. And so the clusters, some of them are really, really, really sparse, and or like really, really, really big. So it's kind of hard to see. But there were some that it was like, oh, there, that one's a keeper, right? And so then what he wants to do is he sort of wants to go through all of these, see which ones he likes, um, and then go back and play with the exposure time, to see what the most ideal exposure time is. So then when he either does a live stream with his own thing or with Skylius, right, he can have a list, right? He can have a list and say, okay, I'm going to show you this one, right? And that'll be extremely, extremely impressive. Hey there, Hip. Nice to see you in the chat.
Hey, Hip. Hip, hip, hooray!
Mm-hmm. Hiptacular Raptor is in the chat with the Yinyang symbol. I don't know what those other things are, but that is definitely Yinyang. Just as a personal side note, I think on the other side of this wall. Yeah, on the other side of this wall, I have painted, right, in my house, a yin-yang, black and white, just like it looks there, except mine is rotated 90 degrees, right? So just rotate it, right? But it's I think it's like a 5-foot diameter one or so. So, and I've got it on this just like intensely red background, right? So like really, really red. It's probably a little bit rude to say, but like a China red, right? It's just like this intensely awesome red, and then the white and the black. Yeah, it's really, really nice. So yeah, it's actually just on the other.
What is the purpose of having a Yinyang, by the way?
Oh, it's just a symbol. It's just a symbol for and while the symbol goes a long way, but at least one of the symbols is sort of showing the duality of the universe, and how there are these two things, right? Black and white, but that they're sort of related, right? You'll notice in that symbol that the white part has a little black dot, and the black part has a little white dot. So some of the white is part of the black, and some of the black is part of the white. You know, it's just a symbol, right? And but it's a cool one, and it's old, right? I mean, it's really, really old. Uh, so yeah, so cheers. Oh, and Hip, I think it was you that posted the um, posted the song, um, the porch song, and I actually listened to that last night, and you know, that was a live thing. I also listened to the studio recording, and that's, you know, uh, that's a really, really, really easy song to play. There's basically two chords, and you know, but there's a lot of diddling around, right? But yeah, I think that's a cool song. I looked it up also in terms of copyright, and um, YouTube has absolutely no problem with that song at all. So in theory, right, that could be played um, 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 on this live stream, and what I'm thinking that I want to do is come up with a way uh, of playing it here live. I don't exactly know how I'm going to do that yet, but I mean, it's a um, the lyrics are so relevant to this live stream that you know, it's almost like a theme song, right? And I do like to think of this as a porch, right? Virtual porch, where we're all, you know, sitting around, just, you know, talking astronomy, thinking astronomy, for, you know, a little bit of time during the day, and that's a really, really cool song. So yeah, maybe at some point uh, soon I'm going to work on that. You know, because that that song, a lot of that song is in the drums and sort of in the solo guitar, right? Um, as I said, you know, there are basically two chords, right? G throughout most of the song, and then part of the chorus has a C chord in it, and that's it. But there's a lot of diddling around with those. So so yeah, I'm going to work on that. And great suggestion. Yeah, yeah. Balance. Yes. Yeah, there's this balance. There's a lot of symbolism in that um, um, yin yang symbol. So yeah, you know, um, um, talking about duality, talking about balance, talking about how things are connected. Yeah, you know, this goes on and on and on. Hey there,
Now,
Christo.
yes, about Crystal Gems Caplet. Now, I want to like ask somebody for the chat and even you, Cosmic. Do you follow the Space Weather Woman, also known as Seven the Scope?
Uh, I I definitely do. I discovered her, five years ago, 6 years ago or so. Um, I don't follow her closely, but
Yeah.
I definitely, you know, keep an eye on her at least. Yeah.
Yeah, so like Seven the Scope had a like little live stream earlier today,
Hmm.
and she was explaining about the hurricane and the conflicting matter of that solar storm might hamper the amateur ops. But
Did she?
I think that was her first time she ever did a live stream, and she probably didn't know about the bells and whistles since she was the most popular and stuff. And when you're, and I think what it is when this is your first time live streaming, and you know there's going to be, and you're popular, and you know there's going to be trolls. At least have a moderator experience things. Why can't she be a moderator? or if you was around, maybe make you as a moderator.
Yeah, yeah, yeah. Well, she'll learn from this, and yeah, I mean she's extremely popular. I didn't know that she was doing a live stream. I need to make sure that I've got my notifications for her turned on, because I definitely. I mean, was that during the day today?
Yeah, that was during the day today.
Okay, yeah. I mean, I've got a day job, so I was out, and you know, um, I'm definitely not able to watch those kinds of things during the day, at least where I am. So, and I think she's in the United States
No.
too, right? So,
Hey, what's up, Crystal Gems? My name is Bobby Burgess, and yeah, it's very nice to meet you too.
yeah, I don't think um, the way that um, Google Hangouts works is that if there's only one panelist, it doesn't actually show up on the screen that people are watching.
I remember whenever we was first was doing it. When I start talking, I show up. Start talking, you show up.
Yeah, and
I don't know what happened to that function.
I can turn that on and off. So now, if you start to talk,
Test 1 2. Test 1 2.
and it'll stay there until I start talking. So
Yeah,
I can definitely.
now I can see me.
Yeah, yeah, yeah. So anyway, there he is. Yeah, I can actually keep that turned off, so it um, flips between us. The only problem with that is that if there's any kind of background noise at all, it'll flip back and forth, and that can be
The
sort of annoying.
ultimate con of doing the automatic and stuff.
Yeah, yeah. But anyway, now you're seeing Bobby for sure. I'll sort of keep that on and see if it works. Yeah, if if there are two or more panelists, then you'll actually um, see them really really small, like on the bottom of the screen. But we need another panelist in here. Hint hint hint. Um,
Yeah,
do
it's
that.
kind of a bit messed up that Uncle Bill was what used to be in the panelists as well.
Yeah, for sure. Um, um,
He
he'll
can
come
use
in.
we can use
He'll come in
his
when he
mouse
wants to.
guy piece again.
Yeah, yeah. Well, he'll come in when he can. He is usually monitoring like several live streams at the same time. So he can't really participate much in one, because he's doing the ninja thing, and he's got you know um, um, 50 screens up on his thing, and he's watching them all. So yeah. But I think when he has things to actually contribute here, he will definitely pop in, and of course he is welcome anytime, as are you all. If you'd like to be part of the panel. Now, you don't have to have a camera. You do have to have a mic at least, right? But um, like if you don't want to be seen, that is completely understood. But you may want to be heard. So either of those options work. It's an and or thing. You can send me an email, cosmiclettuce@gmail.com, and when I start the live stream up, I will send you a link about 10 minutes beforehand or so, and so we sort of have a pre-show and sort of a post-show. Nothing exciting. Nothing exciting at all. It's just me setting up a little bit. filling up the mug and you know, chit-chatting and all of that. So there's nothing extraordinary or anything. But yeah, definitely, I would like all 10 slots. There are 10 slots available for panelists, and I would like to have all 10 slots filled every single day. I think that'd be very, very cool, because then I don't have to talk so much, right? You know, like I've said, the only thing that isn't real about this is me talking. I'm a pretty quiet dude, right? I mean, I like to listen. I definitely like to participate, right? But I like to listen a lot. But with this kind of thing, you know, it's basically just me. Bobby's here too, right? But if there were more of you, part of the panel, that conversation, you know, could be a lot less me and a lot more you. And I think that would be very, very cool. So, you know, just hint, hint. And I'm catching up on the chat. That, you know, get Jaja in here anytime you want. As long as Jaja, you know, is saying things astronomical, more than welcome, anytime. Yeah, just throw me an email, cosmiclattice@gmail.com. And as I said, I'll throw you a link to this live stream, and you can come in. I think, right? I mean, you just have to click on the link, and you pop in here. Is that as easy as it is, Bobby?
Oh yeah, it's easy as 3.14.
Easy is 3.14159265. There's Uncle Bill. See, Uncle Bill is popping in. Very cool. Hey there, Uncle Bill. Nice to see you. See?
What's up, Uncle Bill?
So the hinting worked. Hint, hint, hint. Cool, cool. Well, say hi to everybody, Uncle Bill, just so we know you're there.
Yellow, y'all.
There he is. Painting the panel yellow. Cool.
Yeah, I had to find my audio settings so I could dial down the echo. I knew it had to be blasted.
Blasting. Yeah. And I've got a little...
I can see it's pretty much in carbureting mode and stuff.
Yeah, cool. Cool. Well, awesome. Awesome. All right. Well, I am going to continue. I was over at archive.org again. Now, let me just go through archive.org again. I like to do this from time to time just so you all can sort of see what this is all about. Archive.org is this website. I'm going to go over there now. And what it is, it's a site that is hosted by Cornell University. And what it is, it's a listing of all the latest and greatest papers in a bunch of different subjects, right? Not just astronomy, but as you can see, a lot of physics, math, computer science, biology, finance, stats, electrical engineering, even economics, right? And these are, for the most part, these are papers that have been written and sort of approved for publication. But for the most part, they haven't been published yet. These are called preprints. So they're going to be published, but they haven't exactly been yet. But the authors can send them here, and basically be published. So this is all the newest bleeding edge research that is being done. This is the newest stuff. So all your science communicators, everybody else, they go here, to find all the newest things. And these are updated every weekday, right? So Monday through Friday at about 1 hour UTC or so. Now that varies. Sometimes it's like 0 hours 30. Sometimes it's 1:30. Usually it's around like 1 hour UTC. So Monday through Friday, right? Not on the weekends, not on Saturdays and Sundays, but Mondays through Fridays. And if you have an interest in any of these things, right, this is at least one place to go. Now, this doesn't have everything, right? It doesn't have everything, but oh my gosh, it has a lot, right? It has a lot. And rightly so, at least in my opinion, right? Astrophysics is the first thing, right? So you can, as you can see here, right, you can look at the newest ones out, recent ones, or you can do a search, right? There's all kinds of ways to search. I always just like to look at the new ones. So yeah, let's just do the astronomy ones, because that's of course what this live stream is all about. So in the astronomy section, you'll usually see 20 or 30 or 40 new papers every single day, right? And as you can see, this is for Friday, the 31st of August, 2018. That is the UT time, right? So, and here they are, right? Here are all the latest and greatest papers in astronomy. Well, maybe not the greatest, but the latest ones at least. And just in astronomy, right? This is going to cover a lot of ground, right? I mean, everything from the theoretical, all theory, going all the way over to just the observational, and everything right in between of that too. So it just goes on and on and on, right? So what I do, this live stream starts at 2 hours UTC. So usually around 1 hour UTC, at least on the weekdays, I'll go over to this site and just sort of skim, right? I mean, what I do is I read the title, right? And if there's anything interesting in the title, then I'll read the abstract, right? And that's what this is, which is just sort of like a summary of the entire paper, in sort of a paragraph or so. And if that sounds interesting, and in fact, why don't we go to one that I thought sounded interesting. Let's see if I can find it here. I mean, all of these to a certain extent sound extremely interesting to me, but a lot of this stuff is so over my head that I can't even reach it, right? And if I can't reach it, then it's like, well, I'm not gonna pay much attention to it unless I want to do a deep dive and try to learn things, right? And then I will. But I noticed there was a paper over here that looked kind of interesting. Let's see if I can find it. So yeah, as I said, if you have any interest at all in science or mathematics or economics or stats, this is a really great resource. I really haven't looked at anything except the astronomy stuff, so I'm not quite sure what's part of the other ones. But this one caught my eye. Dust in the Jupiter system outside the rings. So, as you may or may not know, Jupiter does have a system of rings. They're very thin, very faint. In fact, I think, I can't be absolutely sure of this, but I think the first time that they were detected was actually with one of the Voyager spacecraft that flew by Jupiter, back in 1979, and they actually discovered these rings backlit, right? So they were looking back towards the sun after they had passed Jupiter, and they did a long exposure, right? And they noticed that there were rings, right? So that is very cool. And I think subsequently, I think we can actually see these from the ground now. But they're extremely small, extremely faint. But this paper, I guess, is talking about dust, not part of the rings, but further out from Jupiter. So what you can do is you can click on this link here, and it'll just sort of pop up the same thing, right? I mean, this is the abstract here. We'll look at the abstract in a second. But what you can do is you can download a PDF file of the actual paper, right? This is the paper that's actually going to be published. And it doesn't say here where it's going to be. Oh, okay, yeah. It's going to be accepted and published in a journal called Astrodynamics. So that's kind of cool. So we can grab the actual paper itself. And there it is. So let's see. Jupiter is one of the major targets for planetary exploration. The dust in the Jovian system is of great interest to researchers in the field of planetary science. In this paper, we review the 5 dust populations outside the ring system. So yeah, let's just dive into here. Let's see if there's anything else. So they're going to be talking about the environment. They do some modeling, it looks like. So, and as they mention here, dust is a major hazard to spacecraft, right? You don't want dust smashing into your spacecraft. We just heard about a incident on the space station, right, where they discovered this leak, and it turns out that it was a little hole, right? It was like a millimeter-sized hole, and that was most likely caused by some kind of little grain of dust that just was at the right place at the right time and smashed into it, made this hole, caused a leak. Now, you don't want an air leak in the space station, right? It's like a big deal. So, yeah, I think there's a little bit of panic at the moment. Hopefully they have it pretty much under control at this point. But, yeah, just that alone is sort of a good reason, to study the regions of dust. But as this paper is going to point out, it can also tell you things about the other moons and sort of the environment of Jupiter itself. Jupiter is an extremely dynamic environment, just absolutely amazing. All right, so let's see.
Now, I have a question and stuff.
Say that again, Bobby?
Now, when they go through those, I have a question about when it comes to publishing papers and stuff. Do they have to go to like the government organization to like find out if that can be dismissed or accepted, or how's that system works?
So what a scientist does, right, is they do all this work and they write these papers, and then they submit them to a journal, right, some kind of a journal that they want the paper published in. And normally how it goes is that the journal will take it and they'll sort of do, you know, sort of a preliminary evaluation. If they sort of deem it moderately acceptable or so, then they'll send it out to, you know, 2 or 3 or 4 referees, and these people read the paper, and they're usually the referees usually know something about the subject, right? You know, they're not going to send a cosmologist this kind of paper, because a cosmologist doesn't really know anything about planetary science, right? But they'll send a planetary scientist this kind of paper, so they can sort of properly evaluate it, make sure that, you know, what they're talking about, you know, is sort of coherent. They might, you know, check the math. You know, they might check the data. They'll also look, you know, for spelling and, you know, all of that, right? You know, just a basic evaluation. And then the referees will respond and say, yes, I think this paper is good for publication. Or, you know, the referee might say, well, you know, this is good, but I would like the authors, you know, to sort of explain this a little bit more, right? And so oftentimes there's sort of a back and forth process, right? So goes to the referees respond, goes back to the author responds, goes back to the referees. This might happen, you know, 1 or 2 times, maybe. I think a lot of papers, the referees are like, yep, this is okay, right? So once the
referees at any time can either say yes or no.
Look, you went mute there, Bobby.
Oh, can the referees at any time say yes or no?
They can. They are supposed to be unbiased, though, right? I mean, they can't necessarily make a judgment call in terms of like, you know, the scientific quality, right? They are looking for, you know, did the authors do their homework, right? Did they make sure that their math is right? You know, did they look at the data correctly? Did they process the data okay? You know, were they thorough in their work? Now, peer review is sort of a big deal these days, because a lot of people think that that it actually you know, slows down the progress of science because there are biases, right? You know, if a reviewer or referee looks at a paper And it's like, you know what? That's the stupidest theory I have ever heard in my life, right? That is just dumb. I don't care how thorough they are. That is just crazy, right? You know, it's woo-woo. It's just stupid, right? Well, then,
So, like, who's usually got the final say so?
well, once the referees give it the stamp of approval, the journals will publish them for sure. So that's sort of the process, right? So the paper's sent to the journal does an evaluation, sent to the referees do an evaluation. There's maybe a little bit of back and forth there, a little bit. Once the referees, give it the stamp of approval, it's published, and that can actually take months, right? To publish, and so it's really, really cool to have this site where, as soon as it's approved, that paper, can essentially be published, right? It doesn't have to wait for the journal to publish it. It can go right up onto this site, and we can see it weeks or months in advance of when it was, going to be published. So very, very cool. Yeah. All right, so let's take a look here. So they are looking at dust in actually 6 different populations, right? So particles, part of the ring themselves, right? So looking at the rings also. Let's see, 2 grains in the region of the Galilean moons, right? So there are these 4 so-called Galilean moons because they were first discovered by Galileo back in like 1610 or so. He took one of these telescopes that he had gotten from one of his Dutch friends, and instead of looking at ships and stuff on the ocean, he pointed the telescope up in the sky. And it's like, well, what do you point at? Well, you point at something bright, right? Jupiter is really, really bright, so he pointed there, and what he saw was Jupiter itself, right? And then these 4 stars, right? These 4 things that were moving, right? So very, very cool. But so that's why they're called, the Galilean moons. Io, Europa, Ganymede, and Callisto. And here's sort of a graphical representation. So these units are Jupiter radii, right? So Jupiter's right in the middle here, of course, and then here's Io, right? The orbit of Io, the orbit of Europa, the orbit of Ganymede, and the orbit of Callisto, right? I guess, yeah, they're calling anything outside of this solid red circle the outer region that goes from about 50 Jupiter radii out to, as they say here, 300. So they're looking at the grains in this region, right? Let's see. Number 3, possible dust from plumes on Europa. Cool. Small and fast dust streams from volcanoes on Io. Let's see, that's number 4. Number 5, particles in the outer region from the Jovian um, irregular moons. So that's, yeah, that's that's pretty much every other moon is sort of, you know, these weird looking moons. And then dust grains in the regions of Jupiter's Trojan asteroids. And the Trojan asteroids, will, I think they have a graphic of those. So yeah, they, you know, wow, they are looking at a lot of stuff here, right? I mean, just huge amount of stuff. I think they used quite a bit of data to gather this spacecraft data, and also, you know, some ground-based. So they'll probably talk about that next. Okay, so here's here's a graphic of where the Trojans are, right? So here's Jupiter, right? And here's the sun, right? So now these units are astronomical units, right? So 1 astronomical unit is the distance between the Earth and the sun, and Jupiter is about 5 of those, more or less 5. Okay, so these L points here are just the Lagrange points. It's positions in space where sort of the gravitational forces between these two bodies, right? In this case, Jupiter and the sun are equal, right? So there's an L1 point between Jupiter and the sun. There's an L2 point, which is just on the opposite side of the L1 point. There's an L3 point, which is way over here on the other side of the sun. And then there's L4 and L5. And there are actually very, very large populations of Trojan asteroids that you know, sort of form a cloud of objects around L4 and around L5. Now Earth also has these Lagrange points, right? In fact, the James Webb Space Telescope is supposed to be put at L2, right? So out here. If this was Earth, right, L2 would be out here. And I think it's about 1 million kilometers away or something like that from Earth, something like that. But the interesting thing is that Earth also has these L4, L5 points, and people have been looking for objects there. I don't think that they found any yet. Found any yet. I think also, just as an aside, I think there's some kind of an association that's called the L5 Association or something like that. It's a group of people who are advocating that we build a space station at L5. And I'm not exactly sure what the arguments there are, you know, for L5 as opposed to anywhere else, but it's a good point as any.
And I know you're super way behind the chat too.
Oh, am I super way behind? That's okay. That's all right. Let's see. Yeah, it's about 60 degrees or so, something like that. Yeah, cool. So I thought that this was kind of a neat-looking mathematical equation that you know, probably you know, at first glance sort of really, you know, blows the mind, right? Because there's so many terms and there's so many symbols and everything else here, right? But what it comes down to, right, is that this symbol here, and I'm going to blow it up here so we can really see it. All right. So what this is an R with a vector over it and 2 dots. What that is, that's a measurement of um, like accelerative force. So it's just acceleration. That's all what all of this is just a way to get a grip on how these things are being moved around, how this dust is being moved around. And they explain every single term in here, every single term, right? So it's all you have to do is just sort of read this and say, okay, R with a little arrow over it. Let's find that. Here's one, right? Here's one. That's just a vector. Here's a few other, well, okay, that's a different symbol. So G is the gravitational constant, right? So that pops in here in a few areas, right? Here, here, and here. Mass of Jupiter, right? There's that one there. I don't see it anywhere else. J2N, you know, I mean, it starts to get complicated. Point is that all these terms are here and you know, pretty well explained. It's you know, extremely complicated, right? They've tried to take into account quite a bit of stuff, right? Grain charge, masses of the grain, magnetic fields, Jupiter's rotation, taking into account solar wind, right? Not quite sure what the radiation efficiency factor is. Not quite sure what that is. Density of the grain, radius of the particles of these grain. So here's the mass, right? Here's the radii, and there's also, you know, the bulk density. C is the speed of light. So for some reason, you know, that's some part of this.
Okay, Crystal James Captain is saying, what's the script officially called?
What is that script officially called? I'm not quite sure what. Not quite sure what you mean by that, Crystal. Oh, yeah, it's just an equation, right? This is equation 1. That's all it is. Instead of having to write all this out, right, which they do anyway, to sort of explain it, this just shows all the relationships. So yeah, you know, they're taking into account lots of different things. This is what they put into a model. That's why, you know, I've been saying for a long time, you know, that models are really, really great, but they're usually very, very complicated and have a lot of variables, right? I mean, except for things like big G, the mass of Jupiter, the radius of Jupiter, what, mass of the sun, maybe the charge. Well, no, I mean, even the grain charge is going to be changing, right? So most of these things are variables, right? So it gets really, really complicated, really, really, really fast. And yeah, I mean, it flies over the head of everybody because it's just crazy. And, you know, combined with that, right, this is vector algebra, right? So you have to extend this to 3 dimensions of space. right? That's what these cross products are here, and that's why there is a vector, because this, like this R, you know, with a little arrow over it, is actually the XYZ position, right? So hidden in these symbols are even more symbols. So yeah, I mean, it gets complicated, but it's all there. And you know, this there this is just algebra, right? There isn't any there's nothing more complicated here at all. And there's no calculus here. There's no, I guess there's a little bit of trig, right? A little bit of trig. There's no differential equations. There's nothing funny there at all. I might take that back. I think this symbol here might be some kind of derivative. Let's see if we can see what delta is. That's sort of a, yeah, that's a pretty standard mathematical function. So this actually might be a derivative. So maybe I'll take back what I said about the calculus thing. But, you know, you basically plug in the numbers and you get a result for the acceleration there. And, you know, to make a model, right, you have to turn this thing into computer code, and that gets really, really fun. All right, let's keep moving here. Right, we're not going to get into this much because this is just supposed to be sort of a skimming. And as I say, you know, what I like to do is I like to look at the pictures and then go from there. But I definitely wanted to show you that math, just so you can, you know, get sort of a feel for what's involved, get a measure of your level of understanding too. So okay, yeah, here they're talking about dust plumes on Europa, and I guess Galileo, you know, measured these things and actually maybe saw some dust. Right, there was an announcement a couple of months ago that some researchers had gone back and looked at this old Galileo data that was kind of funny looking, and they plugged it into a dust model, right? And that data matched their model really, really well. And so it's like, well, cool. You know, Galileo looks like it probably flew through a plume of dust coming from Europa. Very, very cool. So this is just showing the number of dust particles counted as a function of distance from Jupiter. And as you can see, this dotted line is the orbit of Europa. And they saw, you know, a substantial number of dust particles there. Maybe not so much from Ganymede, but definitely a contribution. And yeah, maybe a Callisto thing. You see these lines that have these tops and bottoms to them. Those are the measurements of error, right? So, for instance, let's get an easy one here. So this one here looks like maybe about 6 plus or minus like 2.5 or so. So maybe it's 3 and maybe it's 8.5, right? It could be anywhere in that range. So that's what those mean. And as you can see, these these bars actually get larger as this number gets larger. So the uncertainty in the measurement goes up as this number goes up. That's kind of unusual, I guess. It usually is the other way around. It's because these are smaller down here. Don't know. So here's a HST image of Europa. That's sort of this background stuff. This is a picture of Europa imaged by Galileo and Voyager. So this image here in the middle wasn't taken by Space Telescope, but this in the background was. And what they're showing is possibly some kind of a plume, right? It's unusually bright. It doesn't look like anywhere else, right? There's no other bright things like that anywhere else, and it's in the right place. So maybe it is, maybe it isn't. It's
say goodnight to Hip.
See you later, Hip. Thanks for coming in. This I didn't really understand. It's some kind of an impact rate, but particles per second. I want to say that this is part of a model of some sort, but I'm not quite sure. Not quite sure. Have to actually dive into the paper a little bit to see what that's all about. Let's see. So, yeah, this is sort of a complicated plot too. So local Jovian time is down here, and then orbit numbers here, and they're showing the dust flux as what? Galileo? Yeah. Sort of flew over or through, these different regions of the Jupiter system. And, some places they found a lot of dust, and some places they didn't find much at all. So what does this mean? Well, we'd have to read the paper to see what these guys actually gathered from that. But kind of interesting. This, I sort of see this as sort of a longitude map, right? Sort of a longitude. I'm not quite sure why it goes from 0 to 24 though, because Jupiter's day is about 10 hours, 10 or 11 hours, not 24. So, I'm not quite sure. Again, we'd sort of have to read the paper, maybe to understand why they chose that axis. But I guess I'm sort of seeing this as a longitude map. Yeah, I don't know. It's going over the head of this reader. Let's see. So the outer region of the Jovian system, there exists a dust population with a nearly constant number density of 10 particles per cubic kilometer.
Cosmic, it looks to me like they broke up the sky using 24 hours right ascension, not true hours.
Huh, okay. Yeah, as I said, I'm not sure, because it says Jovian local time.
Yeah, I see that.
So I don't know how that relates to right ascension. Not quite sure. I don't know. Yeah.
It's just the only way I can make sense out of it, because I have the same problem you do trying to get 12 hours out of a Jovian day.
Yeah. So, diving into the paper would definitely help a little bit, but what we're doing here, at least, is just following our noses, seeing what we can understand, right? Sort of like taking the SAT, right? It's like, if you can't answer the question, move on. So yeah, pretty constant density, not very dense at all, right? 10 particles per cubic kilometer. That's that's pretty empty space. Pretty empty space. I guess they're saying it's coming from the rest of the moons, from impacts and all of that. Kind of cool. Right, so the Trojans, there are two populations of Trojans, one at L4 and one at L5. Let's see if we can get a density here. They're talking about particle sizes and all that. Well, here's the number density. It doesn't give units here, so let's look. So this is in the L4 region, and as you can see, it's not highly concentrated, right? I mean, L4, right, is about maybe like here or so, and these are all the Trojans, right? So, well, at least the dust, dust in the Trojan area. So it is most definitely most concentrated where the Trojans are, but it's spread out, along what, like a quarter of the orbit of Jupiter or so. Let's see, does it give? It doesn't give.
Something else, if I remember correctly, it's possible to have a halfway stable orbit that just misses L4. It's like a kidney bean or a noodle shape. Misses L4, swings around to the far side, misses L3, swings around L5, and then back again.
Wow. Yeah.
Okay. So, yeah, you get stuff that's spread out like that, maybe even on the far side of the sun, too.
Yeah. I would expect to see sort of the same thing down here. Yeah. So, there's all kinds of stuff around, the entire orbit. Here are my units per cubic meter, right? So yeah, again, not a lot of stuff, right? I mean, we're measuring very, very, very small amounts of stuff, right? 6.6 times 10 to the negative 11 particles per cubic meter. We can convert that to per cubic kilometer, right? If we multiply that by 1,000 3 times, so 6.64 times 1,000 times 1,000. Whoops, 6.64 exponent 11 negative times 1,000 times 1,000 times 1,000. So that's coming out to be like 0.06 particles per cubic kilometer, right? So, it's absolutely amazing, that we can measure things that sparsely, but apparently we can, and we can actually get a nice range here too. It's absolutely mind blowing that we can measure those kinds of things. Incredible. Anyway, so yeah, that's I sort of noticed that title, and it's like, yeah, you know, I guess I sort of had a basic understanding, you know, that there was, you know, lots of dust around Jupiter, but exactly what the regions were and how much stuff, you know, they're actually talking about, I didn't really know. But these guys using, and did they actually say? They actually say, I mean, obviously Galileo, you know, they used the Galileo spacecraft. But did they use any other instrumentation at all? They must have. They must have. Ground and space base. Okay, here we go. Yeah. So Pioneer 10 and 11, right, which also flew by Jupiter back in the early 70s. Voyager 1 and 2, which were in the late 70s. Galileo in the late 80s, early 90s. Cassini did at least one flyby of Jupiter. New Horizons did one flyby. Ulysses, which was actually a solar, was or is, I don't know if, I think Ulysses is still going. But yeah, it I think used Jupiter to get itself in an orbit, sort of a polar orbit going around the sun. And it looks like they used HST and also Keck. So cool. Cool. So yeah, just nice to know that, you know, there is definitely dust and it's complicated, and there are these different regions where, you know, you're looking at different densities and different populations of dust. Pretty cool. Pretty cool. All right. Well, it's looking like we're getting a little past time here, so I'm going to stop sharing, get back over here, and I'm going to check the chat really quick. Check the chat. Check the chat. Let's see. All right. Yeah, I think we are caught up. Anybody else have anything else?
I think we're good.
I think we are good. Well, thanks for coming in, you guys, onto the panel. Very, very awesome.
So, Uncle Blue, any more of those cow sky things or no?
Was that a question for me? I actually haven't visited Cow Sky in a couple of weeks, to be honest.
Yeah, I think
Okay.
I think it's about time to maybe get into Cow Sky. You know, some other aspect of it. I mean, it's such a big site, right? I mean, there's just so much stuff there. So yeah, we should probably think about diving into that soon, and you know, maybe looking at like a couple other pieces
Now,
of that.
but you said that you were going.
You completely broke up there, Bobby. I didn't hear you.
Okay. I think we lost Bobby altogether. His video froze too.
I think so. I think so. I'm going to give him a second to see if he can come back here. It looks like
About getting close to.
Yeah, I think he's got a bandwidth problem.
Yeah, you're turning into a robot, Bobby. Why don't you, can you type it on the chat? If you can hear me. If you can hear me, why don't you type it in on...
With the YouTube stuff. Okay, can anybody see and hear me now?
Yeah, you're good at the moment.
Yeah, it's the YouTube. It's causing a lot of resource control to be transgressive and stuff. So I'm pretty much going to have to try it on the phone and stuff from now on.
Got you.
Now
did
you
write.
did just say in the pre-show that you're gonna have you're gonna get an SDR, right?
Yes,
And it's
absolutely.
the SDR Play RSP1.
Yep, that is the one I'm planning on getting for sure. For sure. All right. Well,
Now
I
about
guess.
those SDR Plays. Now the SDR Plays on Windows, some people like it better with SDR Uno, which is their built-in software. Other people like it with the SDR console.
Okay.
But everybody that has the SDR Play not only uses the SDR Uno or the console, but they also do use HD SDR with it.
Nice. Yeah, I'll just have to experiment with those a little bit. All right. Well, you guys, I'm going to get out of here for now. I'll let you go. So thanks for coming in again. It's always awesome to have everybody here. You know, just, sitting back a little bit, looking at a little bit of astronomical stuff, following our noses, having things, fly way over our heads. Just like, what was that? I don't.
Flying aircraft.
I don't have a clue, but I don't mind. I mean, that's how we learn, right? Is to look up and sort of reach, right? So I don't mind that one bit. Sometimes it's a little rough, but yeah, it's all talking astronomical things. So for now, I'm going to get out of here. So I will see you all in a little less than 23 hours, like 22 hours and 39 minutes.
Later, nerds.
We'll be back. So take care, everybody. Bye.
Later.